This chapter is going to be all about solutions, which are solutes, so could be anything, any kind of chemical at all, dissolved in a solvent, which is most often water in healthcare. How can we understand the quantity of the solvent that's carried around within the solution? And this is really important for healthcare because administering drugs in solution form is just a really easy way and a really common way that they are administered. So furthermore, we're going to talk about the nature of water, particularly osmosis, which describes how the concentrations of solution can affect the environment in which cells live. In this module, we're going to really focus on solutions and why they're so important to understand the chemistry of as we apply to healthcare. And so when we're dealing with treatment of patients, a lot of times we use a liquid. And what we're going to see is that this liquid isn't just like liquid in the sense of solid, liquid, and gas, but in fact, it is mostly water into which there is something that is dissolved to make this quote-unquote liquid actually have properties of that particle that we are dissolving in the liquid, right? And when it comes to things like IV fluids or medications or giving electrolytes to patients, antibiotics, or even nutritional needs, a lot of times we are delivering these as liquids in the liquid form, right? We have a bag of IV and that is given as a liquid. But in reality, this IV is not a pure liquid, but a solution that is in fact mostly liquid, a solvent, almost always water, with something dissolved in it, and that's a solute. So in this case, the IV contains electrolytes, and those solids are dissolved in water, and it's diluted to the right amount of the IV solute that's needed, and can be given to a patient. The solvent is almost always water, and the solute, salt, glucose, medication, a wide variety of things. We can deliver all of these things traditionally that may take a solid form or really any form, and give them in the form of an aqueous solution. And as we're looking at aqueous solutions, one of the most important attributes of a solution that we want to track in chemistry and in healthcare is the concentration. How much solute is in a given volume of liquid. And if we consider coffee, if you like to take your coffee with sugar, you can put in just a tiny bit of sugar, quarter scoop, let's say, or you could put in sugar till the spoon stands up. And that second one is going to be a really concentrated sugar solution, a really sugary coffee. That's a high concentration of sugar in the coffee. Whereas the very little amount of sugar, that would be a dilute amount. And note that it's not just the amount of solute, the sugar in the first example, that controls this, but it can be the solvent as well. In the picture on the right, we have the same amount of blue solute, and what we've done is we've taken that same amount but added to double the amount of water. We can see that now because we've added more solvent, the solution has become more dilute. That solute is now spread out over more total solution, and the concentration has dropped because there's less solute per given amount of solvent. And this concentration is always given in terms of this relationship. How much solute is there per something that refers to the solvent or the entire